Second way to get your data into R. If you go to the MoveBank webpage and download the table manually, you can just use the empty read function of the Move2 package, and it will automatically just read in your data as a Move2 object. Inconsistencies again. So if you look up here, the names are, if you download them directly through R, all the names have underscores. If you use the table that is downloaded, that you download manually from MoveBank and then upload it, it has the minuses. It's just the inconsistency between the web page and the API. We can't really do anything about, well, we don't want to fix that inconsistency. We just leave it just so you're aware of it. And this is just important if you're looking for column names. They might be, the name is the same. It's just that there might be slightly different. But what is if you do not have your data on MoveBank? Of course, you can then as well do a Move2 object. So there are two ways to read in. There are probably more ways, but I chose two. The traditional read CSV and the room, which is actually the function that we use within the Move2 package. The beauty of the room package is, so just one second. So with the, where is it here? So with the read CSV, your timestamps are characters. So you will have to deal with them afterwards. With the room package, it recognizes the timestamps, and if your timestamp has the standard format, and it assumes that it is in UTC. So you have to take this into account. It assumes it's UTC. If your times are in another time zone, don't use room because it will just transform it into UTC POSIX. But if that is your case, it's a really nice way because you don't have to manually transform your time zone. But remember, if your time zone is not UTC, don't use this function.
But and you can in hindsight change the time zone. So even if you used room and then the time zone wasn't in UTC, you have to use lubridate and with TZ bring it into UTC and then assign UTC to it.
Yeah, the risk is because everything works, you don't remember and you continue and you have your time zone. Yeah. Just saying.
Yeah.
But if you have because normally data are in UTC, you can use this and it works nicely. It's just if not. But so you guys have the code for not automatically recognizing UTC. I took the CSV, the read CSV option. So the first thing that you have to do is define your timestamp. So you say, my timestamp has this format and is in this time zone. And this is really important to get it right because time formats can be so different and it can mess up everything. If you get month and days switched, then yeah, that's a mess. And that's what Excel does. It switches days and months, and depending on the country your computer is from, it's switched. And if you upload a data set, then it switches the days and the months, and then you don't know anymore what it was. It's a really tricky one. We spent months debugging one of these things, so it was, yeah. Anyway, so we set the timestamp into the right time zone. And then we can build the object stating our data frame, which can be a data frame or can be a tibble. We have to say which are the columns defining the coordinates, in which projection these coordinates are, which column is defining the timestamps, which is the column that will identify your tracks. So it can be individual, it can be deployment, it can be tag, it can be the combination of individual and year, whatever is the unique separate track that you wish to be using. And then optionally, you can also, from this table that you have as an input, if you know, and often it just is obvious, those things that can be associated to each track once. So for example, the species name, I mean, that's just one time that you have to name it, or the tag ID, if for each track you only have one tag on the animal. The study name, I mean, it depends on your table. The sex, the age, if it doesn't change throughout if you haven't recorded change throughout the tracking period. So all these things you can state there, but you don't have to. And then, no. Yeah, you have your Move2 object. That looks exactly the same. So as it was a data frame, you can see it's not anymore a tibble here, which just shows the first entries. It shows the entire. It's a data frame. It shows a different way. It shows all entries basically, or the first 10. Anyway, yes.
Wait, Mark.
So you just mentioned that in a Move2 object, a track can consist of all of the points associated with a particular individual, or the combination of an individual and a period of time. I think you mentioned year. Do you have to specify that in a column, or is that specified when you read the data?
Yeah, I went too fast on that one. So if you have a column where you have the combination of animal name and year, then you can use that column, and it will produce one track per individual per year. But that column has to exist. This function is not smart and does stuff for you. You just have to name the column that you want to use that will be defining your tracks. Normally, we use individuals. That's like that's the first thing we do. But sometimes we want to separate things into more tracks for whatever reason.
Sure, okay, thank you.
And we will be doing more of this segmentation later. It's going to be a big part of what we're doing. It's like spring migration, fall migration, and then you want to look at the differences between spring migration and fall migration, so that's where you do track-specific analysis. So you look at the, I don't know, ground speed over spring migration versus fall migration, and then you do it for individual and specific to either circumstances of fall or spring migration. Yeah.
Okay. So for those of you who have used Move in the past, Move was pretty restrictive, so you couldn't have, so the object building would fail if you had duplicated timestamps, or if the data were not sorted, or if you had empty location, it would just fail. Now, the Move2 object is really flexible. It allows for everything, but you have to check, and you have to organize your data afterwards to make sure that other functions will work on it. So there are a group of assertion functions which you can use to check different properties and then fix if the property is not, if it doesn't have that property yet. So one thing is to ask if your tracks are in the table, if they are happening one individual, the next individual, the next individual, or if they're all mixed up. In this case, in this data set, one thing I forgot to say. So we're going to be switching between different data sets for different examples because it gives the best example. So we can't use one data set throughout because to make the point, we choose the correct data for this. So this data set has duplicated timestamps, and that's why I chose it here. So in this case, yes, the data are, because it's only one individual, it cannot be ungrouped. But if your data is not sorted, in this line, you could sort your data. Now, the next question is, are your timestamps ordered within each individual or within each track? In this case, yes. If you get the answer false, here's a line of code which will arrange the timestamps within each track and order them. Now, duplicated timestamps. Are there only unique locations? No. So let's have a look at how many duplicated timestamps we have. Over 1,000 duplicated timestamps. And duplicated timestamps, there are many reasons for duplicated timestamps. One really common one is two different transmissions of the, so if you have GPS data, you have two different transmissions. You have SMS and GSM, and these are causing duplicated timestamps. When you remove duplicated timestamps, you have to think about, well, it's better if you think about why you have them, so you keep the correct one and remove the ones, so you know what you're doing. Often, just removing a random one works fine, but you should like think a second, like why do we have duplicated timestamps in this data set? So we provide different, oh, I just saw a typo here, okay. There are different ways to remove these duplicated timestamps. So one, we provide one function in the package. And in this case, what it does is of all the duplicates, it groups the duplicates and it just takes the first entry and drops everything else. You could also just take the last entry and drop everything else, or you could just take a random position from the group of duplicates. This is one way of doing it. Another way of doing it, which is in this case, this stork has a EOPS tag, and it has this GSM SMS duplicates. And often the SMS data that come in only have a few columns with information, and everything else is NA. And probably for analysis that you're doing, you might want to have also all the other information. So to not lose it with, I put this piece of code together with the help of Bart, the developer of the package. And here what we do is we take the column that has, we take the entry of the duplicates with the least columns with NAs to keep as much information as possible of the duplicated data. And then because you mess with the data, you again have to arrange it. That's why the 2 lines below here, the arranging the data has to happen. So if we run this and ask like, does it only has unique locations? Yes. And then the last thing is the empty coordinates. So often missed fixes are recorded, timestamp is recorded, but there are no locations recorded. So for many analysis, we have to remove them. If you have location and non-location sensor within the same object, the non-location sensors will have an entry of empty locations. So if you remove them, you're removing all your acceleration data, just so you're aware of it. The missed fixes can be informative, but Martina will tell you more about this later on. But for now, we just remove them. Because here, it's like, are there no empty locations? No, there are empty locations. So we just filter those where the locations are empty. All good? I have to speed up a bit, because if not, I never manage to get through the code. But feel free to ask questions, though. So some basic manipulation. So some basic manipulation of the Move2 object. So now we go back to our example, because it has an example data set of the fishers, because it has multiple individuals and it shows nicer. So as I said at the beginning, there are 2 columns that are really, really important. And that is the column that defines time and the column that defines the track identifier. And it's flexible. You can change it. You can say like, I don't want this column of time because I actually want to use local time because my animal is moving within one time zone. And for my analysis, to understand them better, I want local time zone. But you want to keep the UTC time zone for the error reason. And then you can assign another column with the times. And with the track IDs, it's the same. You might want to say like, actually, I don't want individuals, I want deployments. Or you have deployments like, actually, I don't care about the deployments. I know that there are not years of gaps between the deployments. I just want individuals, so you can change them. So to know which are the columns that are actually used, there are these 2 functions, which return the column name that is used to define time and the column name that is used to define the track ID. And then we have a set of functions to pull out certain information of the Move2 object. So this additional table with the track data information can be pulled out with the empty track data. So you see here, you just get the data frame with the information associated to each track. If you want to extract the time of an object, please do not use $ and whatever column name, because you cannot be sure which is the column name that you're using. So for that, we have the empty time function, which actually pulls out the time that the object is using and provides you with a string of the timestamps. If you want to get the track IDs, you can use the empty track ID function. And here we just look at the unique. So here you have the names of all the track IDs that are currently being used. You can find out how many tracks there are in your object. And for example, you can also look at how many locations per track you have. Given that it's an SF object in many aspects, to get the spatial information, we use SF functions. So to retrieve the coordinates, we use the ST coordinates function of SF. The same goes for, so here you see it still has empty locations. This data set has not been cleaned yet. We use the STCRS to retrieve the projection, and we use the ST transform of SF to change the projection, because often, so you will hear this later on in the week, but if you're using spatial data, mostly like rasters, you mostly will want to reproject your data into the projection of the rasters, and not the rasters into projection of your movement data, because it's much more easy to and quicker to transform points in their projection. So you can use this function, and now you can see that the projection of this object has changed to this EPSG. I've been talking quite a lot about all these variables that you can download from MoveBank. So if you have an object that is containing data from MoveBank, you can use this MoveBank get vocabulary function, which will provide you the definition given by MoveBank for each of the attributes that is contained in your object. So this is really nice. You can also get the definition of specific attributes, but this way you get, like, for all your object, you get the definitions of each of the attributes. Any questions? Okay. So sometimes, we have these two tables, the track table and the attribute table. And sometimes, for some specific reason, we want to move attributes from one table to the other. So mostly it happens that we want to move attributes that are in the track data to the event data. And for that, we have the two functions that does this moving the attributes. So if we have a look at this object, we can see that here we have the species name and the tag name. And if we apply this function to move the attributes from the track data to the event table, we can see that now it has been, that these two attributes have been moved, that they are now in the event table associated to each location. And if we have a look at the track data table, we see that now we only have 2 columns instead of the 4. They have been moved up. And the same you can do the same, moving data from the event table to the track data table, but you have to think about this, because it has to match. So you only can have one entry per track. So you cannot say, like, I just move temperature, which is one entry per location, to the track data. It doesn't make sense, because it doesn't work. You have to have one entry per track. It will just throw you an error. So just you think about this. So as I said before, you might want to select a different attribute to define your tracks. So you can use this empty set track ID function, and here we change it. So now you can see that the column defining the track ID is not the local identifier, but is the tag ID identifier. Questions? Okay. To manipulate the track data table, we have added some adapted functions from dplyr So from the common verbs, the select to work on rows, the filter to work, no, the select to work on columns, the filter function to work on rows, mutate to work on transforming columns, and the group by function, we have done an extension that will work on the tracking data, on the track data. So you can manipulate that table without having to extract it from the object. Just within the object, you can manipulate it, which is really handy. So for example, I just want from my entire object that from my entire study that I've downloaded, I actually only want these 2, 3, 5 individuals. So you can use the filter track data. So this is the adapted filter function for the track data. And you can choose just these 2 individuals. So now you can see that the entire Move2 object, which contained, I think, like 8 tracks, now only contains the 2 tracks. You can do that if you use the argument track ID, it will use the track ID to filter, but you can also use another column that is in your track data table to filter your Move2 object. So in this case, we don't use the track ID, but we use the tag ID. So we just want this tag. So now it reduces the entire Move object to just containing the track that is associated with this tag. We can also use the select track data function to reduce our track data table to just the specified columns, in this case, just to 1 column. We can also add data to the track data table. In this case, the name of the individuals contain also the sex. So we extract it and we add it as a new column. And now you see the data set has a new, the object has a new column containing the sex. We can also use the group by track data function to group the data in different ways. In this way, for example, we want to group it by the column sex. And here we then get the table that contains, in this case, which is the tracking period, when is the start and end of the tracking period for each of the sexes, or we want to know the number of locations per sex, for example. But there's like a world of options, whatever you need, whatever information you need. And the same goes, of course, for the event table. So the event table is the one that contains the locations or the non-locations, so each of the events. And here you can, for example, just filter, saying that the specific column should have a specific value. So here, for example, you can filter the data. So the visible column is set to true. So in MoveBank, you can manually mark outliers or use functions that are within MoveBank, and then the locations get marked as visible or non-visible, visible true or false. So if you have manually marked the outlier, they will be marked with visible false. So you can then afterwards filter your data. This said, the MoveBank download function in Move2 automatically sets the visible to true, but you can say visible false, and then you can download the entire thing, because sometimes you want to reevaluate what these outliers were, and you might want to download the entire data set and make your own cleaning of the data for whatever reason. You can, of course, also just reduce the event table to certain columns and drop everything else, or you can summarize your data. For example, here in this data set, there is a attribute where the behavior was classified. So here, for example, you can just look at how many locations do I have in total for each behavior. So these are just, some examples. But this is basically just using the dplyr functions, you'll be fine. So, as I said, the Move2 package is on cron for about 1.5 years, and Move is kind of maintained to the bare minimum. So it's alive, but we are not developing or fixing major issues. Besides, a set of functions that have not yet been transitions. So all the Brownian bridge, so the space, the Brownian bridge, the Gaussian bridge, movement models, the corridors, there's some functions that have not yet been adjusted because they need lots of work and the time has not been found yet, because it's not just changing it to Move2, but just improving the, as we're at it, we want to improve the entire thing and make it better and faster. And that has not happened yet, but the plan is that it will happen at some point. So throughout this course, and also when you do your analysis, you might have to go back to the Move package. So there is a function to transform a Move2 object into a Move object or a Move stack. So in this case, we just use the function, and then we get a Move stack. And if you have your Move or Move stack object, you can then, with the function mt as Move2, you can easily just read it in as a Move2 object, and there you go, you have your Move2 object. The mt as Move2 also reads in the track object of the library AMT and also of CTMM. So you can put an object of type track XYZ, XYT, or a telemetry or telemetry list object into this function, and it will convert it into a Move2. So, last part, I think. Now we have this data. How can we save it? Because we don't want to download this data over and over again. So there are several ways how to save this data. One of them is the RData extension, which has the advantage that you can save multiple objects within one file. The disadvantage is that when you load that file, your object will be named as you named them when you save them. So when time passes and you load that and you already have like lots of objects in your environment, you have no idea what has just been loaded because there's no message, no nothing. The objects are just in your environment and you really have to know what you're loading. But it's handy if you want to, if you keep track of your names and want to save multiple objects. If you only want to save one object, the better option is to use the RDS extension. In this case, you can only save one object, but when you read it in, you give it a new name. So you actually know what you're doing, and you actually find your object, and you have like, data information in this extra table. We might want to just take all this information and put it up in the event table, so it gets also saved in the geo package, because if we don't do that, all that information that was in the track data just gets lost. So we move all the information up to the event table. We get rid of the empty locations, because if not, you will get an error when you try to save this. And then one thing just to save space is you might want to remove those columns that are anyway just NA, because sometimes MoveBank, or not MoveBank, just the data that you have, there are columns that are all the values are NA, so they're useless, so you might want to just remove them. And then you can use the ST functions to write the geo package, and once you have written it, you can read it into QGIS, for example, but you can also upload it into R with the ST read. There is, so this one, sorry, should have done this. Huh? There is a function in the Move2 package, the empty segments, where segments, so the, just put this. So it's creating an object with the lines connecting consecutive points. So you have one line between each consecutive point. So you have all the segments for all the tracks. And those you can also save as a geo package. And then finally, what you can also do, you can use this empty track lines function, which will give you, I'll show you in a second here, you will get one line per individual. So your you just have that one line per individual, and often that's what you want. For plotting, we use it a lot, but also if you want to see your data in QGIS or in Google Earth, you might just want the line. So this can also be saved as a geo package. The points, the segments, and the lines can also be saved as a KML with the SF functions. And they can also be saved as a shapefile, if you must. I mean, given that GeoPackage works nicely, you might not. But anyway, if you want to, you can also save it as a shapefile. Here you have to take into account if you have an object with lots of attributes, shapefile has a maximum length of column names, and it shortens them, which can lead to duplicated column names, which can lead to an error. So for this reason, if you have lots of columns in your data, you might just want to select those that you really need to keep to save the shapefile. Yeah, just to avoid the errors. And the last is, how would you save a Move2 object as a CSV? You can do this. It's not really straightforward because it's not just a flat table that you convert, that you can save. There are little things. It took me a while to figure out all the errors, and that's why I now put all the code here. So the first thing you have to do is, I'll use this study for an example. So here my point was to show you the track data table, in this case, has 76 columns. So that's why I remember to take the track data table and put it to the attribute table, because if not, you will lose all this information if you save it as a CSV. So this is the first thing we do. We move all the track attributes up to the event attributes. And then, given that the locations are are a geometry, you could save this geometry column, converting it into a well-known text. The problem is that if you want to use it in another program where you need the X and the Y in separate columns, we have to add them to our table. So I just name them location long, location lat, but you can give them whatever name you want to. And then we don't need the things duplicated, so we just drop the geometry of our Move2 object. So now if we look at this, it's actually, so it still says it's a Move2 object, but it's not anymore an SF object, definitely, because it's missing all the spatial information because we just dropped the geometry. Now up to here, you have a data frame. So you can save this as an RDS data frame or work with it with other functions that explicitly need the data frame with all the information. But if you want to save it as an actual CSV, there are other things that you have to take into account. In the track data table, if you have MoveBank data, you will have the main location of the study, the location of the deployment on, the location of the deployment off, and the way that the Move2 package does of each of these locations a geometry. And geometries cannot be saved as a CSV. The CSV gives an error. So here what I did is I looked for all of these geometries throughout all the table and then converted it into well-known text. The advantage of having, you could also, it's lots of work to go through all of them and give them a long lat to all and make 2 columns to all of them. So I thought this was a good option because when you read in so this is the well-known text kind of format. So when you read in this CSV again in R, you can say, I want this column to be a spatial point, and SF transforms the well-known text into a geometry. So this is handy if you go back and forth. Now, another thing that I discovered is that if you save a CSV with the timestamps, if it's midnight, so 0000, it will only save a date and not the time. The time disappears. So if you upload this somewhere else, you have a mix of dates and times, and it's just a mess. So therefore, what I did is I converted the time and gave it and ensured that the form and gave it it's actually now and forced the format to have also if it's MoveBank data, it often has milliseconds. So that's why I forced the format of the timestamp to have milliseconds and to. Yeah, that's the way that we want it, and it's a character, actually. So by doing this, it doesn't have the POSIX at the beginning. So if you would write POSIX, it would be a timestamp in a timestamp form, in the POSIX format. But by just having format at the beginning, it's converted into a character with milliseconds, like with entire timestamp. So that doesn't disappear anymore if you save it. And now, optionally, here again, I remove optionally the empty columns. And then, given that the track ID is flexible and the time column is flexible, if you save a CSV and go back to it 3 years later or even like a month, well, for me, like 2 weeks is enough, you back, it's like, which was actually the column identifying track. So my solution is I sort them, and the first column is the track ID, the second column is the timestamp, and then location long and location lat, and then everything else. So I know these 4 columns are the important ones that are defining what I had when I saved the CSV. And yeah, and then you can save a CSV and everything works without an error. And I actually managed to get to the end of the script. Okay, do you have any questions? You're like just, overwhelmed. It's normal. Just when questions come up, approach us and we'll.
What was the motivation? Thank you. What was the motivation for this Move2 package to separate the track features?
Weight. So, if you have like the 76 by 20 million, it's way more heavier than you have it just for the 5 individuals that you have there. Yeah, and additionally to that, like the weight thing, so we went through the trouble to go and make everything a factor that can be a factor, so we are trying to reduce the weight of the data to the maximum. So this is for MoveBank data. This is just for data that are external to MoveBank. I mean, we can't know, but for all of them of MoveBank, we assign to each attribute, so we have all attributes listed, and then to each of them we assign, one thing that is really important I forgot to say. Here, it's already, I'll get back. So we assign the correct format, so if it's, because in MoveBank you also have factors, so we assign the factors with the levels, and the character when it's a character, numeric or integer. So we really try to save as much weight as possible. And then additionally, we also assign units because all the MoveBank attributes, well, not all of them, but those that have units. So we actually, when you read in data, units get assigned. And you can see here that the barometric pressure, the unit is the bar. So for MoveBank data, you have for all attributes that have units, the units are assigned correctly.
And when
No, go ahead.
and when these track features are then moved to the event, the first bit, it automatically just lines up the way it needs to.
So there's always one column that is double. So in this, like if you have individual local identifier, it will be the local the individual name will be in the event table and will be in the track table. So it knows which belongs to which. If you change it and you have deployment, you will have the deployment column in the event table and the column in the deployment column in the track table. So there's always one column that appears in both places because that's the linkage between both of them. And here again to the units, you see here are all the column names And here between square brackets, you have all the units of the different attributes that have units.
Cool, thank you.
Sorry, I just had a question about the duplicates. In MoveBank, my understanding is that if I upload the data automatically, two timestamps, if there are two entries with the same timestamps, one of them gets, no?
No.
Okay.
You can choose to do that.
Okay, so, okay.
You can choose that now to do that, okay. But the default setting is MoveBank is a database. It doesn't clean the data for you. You just save everything. It's not,
Okay,
yeah.
now that was, especially when you have the live feed coming in maybe on one side, and then you retrieve a caller, and then you upload those. My understanding was that there was this opportunity.
Yeah.
Okay.
You can have the option, yeah.
And then you have to, is it automatic or there is a parameter that you can choose to select which one?
So I think that's the thing. So that's, I think in MoveBank, I'm guessing that if you select it, actually everything gets saved, but you have visible and non-visible? Or does
Probably,
stuff? Yeah. So then you can go back. You can download the code, and you just, it's in some vignette, there's an example. No, I think there's actually in the code today or tomorrow, there's an example of how to download data where also the visible false get downloaded, and then you can reassess which one you actually keep.
So when you were talking about the geo package, and you mentioned that we can, if necessary, go into a shape file because of some requirement that you need. Is it possible, if you get environmental data from a shape file, to transition into geo package? Like the other way around?
Upload the, so you have a vector of roads?
Yeah, we have like environmental data or something that
so
it
you
is a
upload it
shapefile.
into R with so you upload you read in the shapefile into R, and then you just save it with the st write function as a geo package, and there you go.
Okay.